Hey there, so finally the wait is over. In this video, we are going to discuss about how integers are stored in the memory. Now in the previous videos, we have cleared the background to learn this topic, that is how integers are stored in the memory. So for that, we have discussed about how we can convert decimal number into binary. We have also seen how we can convert binary back to the decimal. Now to understand this topic clearly, what I'll do is I'll create one simple variable. So let's create one variable of integer type. I'll name it as, let's say, I_var, and let's also initialize it with value 23. Okay, so what happens when we write this line? What happens when C++ scans this line? What happens in background? So we know that whenever we create any variable or whenever we declare any variable, what C++ does is C++ allocates memory for our variable, and we also know what is going to be size of that memory. We know this now because in one of the previous video we have discussed that for integer data type we get 4 byte for our variable, right? So this variable is going to be of 4 byte size. 4 byte is nothing but 32 bits. Okay, as simple as that. Now this variable is going to have a name, and in this case the name is I_var, and in this variable we are also putting the value which is 23. So this 23 will be stored in this variable. Now we know that whatever things we store in the memory, they are going to be stored in the binary format. So right now, while sake of writing, I am writing 23, but actually what is going to be stored in the memory? While storing, it is going to store binary of 23, or it is going to convert 23 in the binary form, and it's going to store binary of 23 in the memory. So what is the binary of 23? I think it is 10111, right? Now if you count the bits over here, so these are just 5 bits, but for integer we are getting 32 bits. So over here on left hand side we have to add like number of zeros. So if I add 3 zeros over here, this becomes group of 8 bits, right? So this is 8 bits group. This is nothing but 1 byte. In remaining 3 bytes we are going to have all zeros. So it will be something like this. See, if I have 4 byte space, okay, just focus very carefully. I'm going to have 4 byte space. 1 byte is nothing but 8 bits. So in this byte I'm going to have 8 zeros. In this byte also I'm going to have 8 zeros. In this byte also I'm going to have 8 zeros, and in this byte I'm going to have 000 followed by 10 followed by 111. So in this way the data is going to be stored in the memory. So I hope this is very clear to you now. It's very simple, it's very easy. Whenever you are storing any number in the integer, it's going to be stored in its binary format, and now we know that how we can convert a decimal value into the binary, and this is the conversion for 23, and so in this way 23 will be stored in the memory. Now let's see it from very basics. So what we do at very first, at first we write our code. Okay, so let's say we write our code. Let's say name of our code file is, let's say, data.cpp. okay, let's say this is the file that we have created, and in this file let's say we have written the program, and in this program let's say we are creating this variable. Okay, now what we do after writing the code is we give this file to G++, and G++, we know that G++ is set of tools. So after giving this file to G++, what we get as the output is we get a.out file, which is an executable file. See, this a.out file is on Linux. On Windows you are going to get a.exe, which is again an executable file. Now where these files are stored? Are they stored on your primary memory, which is usually RAM, or I'll say random access memory, or are these files are stored on your secondary memory? Just try to think about it. See, these files are going to be stored in secondary memory. Okay, I'll tell you the reason why. See, let's say you write program now, and let's say you shut down your computer and you again start it back, let's say tomorrow. In that scenario as well, this file is going to be present on your PC, right? So that means it's stored in a persistent storage, which is your secondary storage disk. Similarly, this a.exe or a.out file, if you create it today, if you shut down the computer and if you again power on tomorrow, your file is going to be there on your PC. That means again this file is also stored on your hard disk drive. So I will say that these two files are stored on your secondary storage disk. Okay, so these files are stored on SDD or secondary disk drive, I'll say. Okay, or we can also call it as hard disk drive. Okay, now what happens when we fire this command, that is ./a.out, or in case of Windows we fire ./a.exe. What happens when we fire this command? So whenever we type this command, we instruct our operating system that you want to execute this program. See, this a.out or a.exe is nothing but an executable program or executable file. Whenever you type these commands, you instruct your operating systems that you want to execute or you want to run this program. Now, as we have discussed in one of the previous modules, that whenever you want to execute any program, basically that program is going to go to the processor, and then processor is going to read each and every instruction of your program, and then it's going to execute it. And for this entire process, your executable program needs to be on your primary memory. See, we have already discussed this thing in one of the earlier module, that whenever you want to give any instruction to the CPU, that instruction needs to be present on your primary storage. And the reason is, primary storage is an efficient storage. It is faster as compared to the secondary storage, and as our CPU is faster, it needs to have an access to the faster storage. Hard disk drive is not a faster storage. That's why your program needs to be loaded on your primary storage device or your primary disk, which is your random access memory. That's why what happens is, whenever you type this command, what operating system does is, let's say this is your random access memory. I'll just write it over here. Let's say this is your RAM. So whenever you type this command, what operating system is going to do is, on RAM, operating system is going to allocate some memory for your program. Okay, so this is the memory for your program. Let's say data, your program, I'll just call it as data program. Okay, so whenever you type this command, your operating system is going to allocate some memory for your program on primary memory, which is your random access memory. Now there is one small term, just try to remember this term. See, whenever you execute your program, it is called as process. Okay, so basically what is a process? An executing program is called as process. So whenever you type this command and whenever your program starts executing, your program is called as process, or your program becomes a process. Okay, so what is the process? I'll just again repeat. Process is nothing but an executing program. Okay, and always remember, on your random access memory, you get memory for your processes. Okay, so let's say you have Google Chrome open, let's say you have Visual Studio Code open, and let's say your a.out program is also running. Okay, so basically you can say that in your RAM you have three active processes: your Google Chrome, your Visual Studio Code, and your a.out program. So what is the process? It's an executing program. Always remember, on RAM or on random access memory, you always assign or you always allocate the memory for processes. And your programs, so what are the programs? This CPP file and this a.out file, we can call them as programs. So your programs are always stored on secondary memory. Okay, see, what is difference between this CPP program and a.out program? This program is in binary, whereas this program is in C++. That's the only difference. But ultimately both these files are program files. But whenever you type this command, your program becomes a process and it gets loaded on the RAM. Okay, so this is the difference between process and program. Process is an executing program, and on your RAM you are going to get memory for your process. Now let's try to understand for what purpose this memory is used. Okay, so whatever memory you get in the RAM, this is used for storing instructions of your program plus storing your data that you handle or you deal with in your program. So for storing the data you use variables. So your variables are also going to get memory in this space. Okay, so this space that you are getting for running your program is very important. In this space your instructions are also going to get memory, plus your variables are also going to get memory. Always remember, whenever you run any program and whenever you get space for your process, your entire program needs to be managed in that space, and that's done by the operating system. as a programmer, we don't have to worry about this. We're just understanding how this entire thing happens in the background. So always remember, whenever you get space in the RAM, your entire program is managed in that space, whatever space you get for executing your program. And what things are getting stored in that space? Instructions of your program, the code that you write, so instructions, we call it as instructions, and your variables in which you store the data. So those variables are also going to get space in this memory, which is getting allocated for your process. So in this way things runs in the background. So whenever you type /a.out command, this is what happens in the background. Now in this video, I also want to talk about one important topic, that is range of a variable. Okay, so let's quickly discuss about that. So whenever we discussed about size of the variable, size of the primitive data type, we talked about how much space integer variable gets, how much space character variable get. So in that there was one column called as range. Okay, we also saw that for character the range is -128 to +127. So in this video I want to talk about range, how we can calculate the range, how that number is coming. So let's quickly get started. For that, let me clear out the board. Okay, so first of all, what is the range? Range is nothing but the minimum and maximum value that you can store in that particular variable. So let's say if I say that range of a particular variable is, let's say, -128 to +127, that basically means that you can store values which are ranging from -128 to +127 in that variable. So that basically means that you cannot store value which is, let's say, lesser than -128, and you cannot store the value which is greater than +127. So basically if I want to save, let's say, -129, then that won't be allowed, and if I want to save, let's say, +128, then even that is not possible. I will not say it's not allowed, but that's not possible, because the range of that variable is limited to -128 to +127. If you try to save these values, then maybe you will get some unexpected result. Okay, so let's quickly see how we can derive range of any variable of any size. So let's, for our understanding, what I'll do is, at first we'll see what is going to be the range of a variable if that variable gets 1 bit of size. Okay, let's assume that there is a variable which gets 1 bit of size. See, I'm talking about bit, not byte. Okay, 1 bit, not 1 byte, because 1 byte is 8 bit. I'm just talking about 1 bit. So let's see what different values we can store in this 1 bit. So if we have just 1 bit, then we can store 2 different values in this bit. The first value is going to be 0 and second value is going to be 1. So one single bit is going to store 2 different value, or it can store 2 different value at a time, 0 or 1. Okay, let's say we have 2 bits for storing the data. How many different values we can store? Okay, if we have 2 bits, so if we have 2 bits, we can store 4 different value. I'll say, see, the first value is going to be 0 0, then we can also store 0 1. See, these values are in binary. Okay, then we can also store 1 0, and we can also store 1 1. Now if we convert this value to the decimal, 0 0 is nothing but 0 in decimal, and 1 1 is nothing but 3 in decimal, right? Just try to convert these values in decimal. You will get to know that this is nothing but 3 in decimal and this is nothing but 0 in decimal. So if I want to talk about this variable which is of 2-bit size, what is the minimum value it can hold? It is nothing but 0. This is the minimum value this variable can store. And what is the maximum value this variable can store? It is nothing but 3. So what is the range of this variable? Range of this variable is nothing but 0 to 3. In this way we can derive the range. Okay, let's say we have a variable of 3-bit size. Let's try to understand what is going to be its range. Okay, see, in 3-bit variable we can store the minimum value which is going to be 000, right? And this 000 is nothing but 0 in decimal, and the maximum value that we can store is going to be 3 times 1s, and 3 times 1s is nothing but 7 in decimal. So range of a variable which is having 3-bit size is nothing but 0 to 7. So in this way we can derive range of any variable. Okay, so the minimum value is going to be 000, maximum value is going to be 111, and this is the range. And let's try to understand one more important thing, how we can get to know that how many different value a particular variable can store, how many different values a particular variable can store. See, in this case, in a variable of 1 bit size, we can see that this variable can store 2 different values. In this case, you can see that this variable can store 4 different values. Okay. Now, how many different values this variable can store? So let's try to create a generic formula to understand how many different values a variable can store. So in this case, our variable is of 1 bit size, and in 1 bit variable size we can store 2 different values. In 2 bit variable size we can store 4 different values. So you can observe one pattern over here. So let's say if we have a variable of n bit size, I'll say that in general we can store 2 raised to n different values. See, let's assume that n is 1. In this case n is 1, right? In this case variable is of 1 bit size. So if n is 1, 2 raised to 1 is nothing but 2, right? 2 raised to 1 is 2. So 2 different values can be stored. When n is 2, right, in this case n is 2, so 2 raised to 2 is 4. So in this case 4 different values can be stored. In this case n is 3, so 2 raised to 3 is nothing but 8. So in this case, if we have 3-bit variable, in this case you can store 8 different values. Let's say if you have a variable of 1 byte size, 1 byte is nothing but 8. So in this case your n is 8. So in this case you can store 2 raised to 8 different values, and 2 raised to 8 is nothing but 256. So in this case you can store 256 different values. Okay, so in this way you can try to find out how many different values a variable can hold, and you can also find out the range of any variable. Now there is a major problem in our calculations. Now let me just tell you what is the problem. For that, let me clear out the board and then I'll explain you what is the problem in our calculations. Let's take example of 3-bit variables. For 3-bit variable, we are saying that the minimum value that we can store in decimal is 0, and the maximum value that we can store in decimal is 7. So this is the minimum value and this is the maximum value, and we are saying that the range of this variable is 0 to 7. What's the problem over here? The problem is we are not considering the negative values. This is the very big problem, right? We are not considering the negative values. We are just talking about positive numbers starting from 0 to the maximum number that it can store. So whenever we are talking about the variables, whenever we are talking about the integer variables, I'll say, we also need to consider negative values, because integer variable is also going to store positive as well as negative values, right? So this is the problem basically. Now how we can solve this problem? So basically in our calculations we should also consider positive as well as negative value, and for that I'm going to tell you one very interesting thing. Okay, so let's take one example. What I'll do is I'll give you one number. Let's say the number is 1000. Just try to convert this number to decimal. Okay, so try to convert it into decimal. So this is 2 raised to 0, this is 2 raised to 1, this is 2 raised to 2. So 2 raised to 2 is 4, so this is nothing but 4. 4 plus 0 plus 0 is nothing but 4. So 100 is nothing but 4 in decimal. So this is how you convert any binary to decimal. Okay. So let's say in these three, if I store 100, so you will say that this is nothing but 4. Now just try to convert this number from the method of converting negative number back to decimal. So if we see the method of converting negative number to decimal, we know that while converting negative number to decimal, what we first have to do is we have to take ones complement. So the ones complement of 100 is going to be 011. Then we have to add 1 to it. So after adding 1 to it, 1 plus 1 will become 0. There will be 1 as carry. 1 plus 1 will become 0. Then 1 will be carry. And then 0 plus 1 will become 1. Correct? Now if you convert this 100 back to decimal, then this is nothing but 4 plus 4, right? It's again the same number that we are getting. And what you have to do is you have to add minus sign in front of it. So after adding minus sign in front of it, you will get the number, you will get the negative conversion for the number. Now one important question, how a compiler will get to know whether to convert a number as a positive decimal number or whether to convert a number as a negative decimal number, because the methods are different. For positive we are directly converting it into decimal, but for negative first we are taking one's complement, then we are adding 1 to it, and then whatever number we are getting we are adding minus sign in front of it. So the methods are very different. So how a compiler will get to know which method to follow? This is a very important question, and answer of this question is very easy, that hides in this bit, which is very important bit in any variable. This bit is called as most significant bit. It is also called as MSB, or it is also called as sign bit. Okay, this bit is very important. See, whenever we create any variable, the leftmost bit of that variable is called as sign bit, or it is also called as most significant bit. Now this bit is responsible for holding a value which indicates sign of that number. See, this is very important. See, this bit is responsible for holding a value which is going to indicate the compiler what is the sign of that number or the value that we are holding. If this bit is 0, see, I'll just write it over here. See, if this bit is having value as 0, that indicates the compiler that it is a positive value, and if this bit is having 1 value, it indicates the compiler that it is a negative value. So how compiler is going to get whether to convert this number into a positive number or into a negative decimal number? So it's going to be with the help of this bit. If the value of this bit is 0, then compiler is going to convert it using method of positive number. If the value of this bit is 1, then the compiler is going to convert this number by using the method of converting into negative decimal number. Now the job is very easy. Let me just quickly clear out the board from here. Okay, so now the job is very easy. See, now we have 3 bits. If we have to store a positive number, then the leftmost bit needs to be 0. It needs to be 0. So if this bit is fixed, then we just have only 2 bits for storing our data, the actual value. And in these 2 bits, we can only store 4 different values, 0, 0, 0, 1, 1, 0 and 1, 1. So the maximum positive value that we can store is going to be 1, 1, which is nothing but 3, plus 3, right? Why I am calling it as plus 3? Because this bit is 0, 0 indicates positive number, so this is going to be plus 3. And if we set this bit to 1, then again we have only 2 bits for storing our data. Again the possibilities or of the different values are 0, 0, then 0, 1, 1, 0 and 1, 1. Okay, and these numbers are going to be negative numbers. Okay, now let's try to convert these numbers to decimal. So if we convert 100 to decimal, so let's try to convert it. See, 100, take 1's complement of it, so it is going to be 011, add 1 to it, it's going to be 001. See, 100 is nothing but 4, so this number is nothing but minus 4. Okay, let's also try to convert 101 into decimal. So if we convert, let me just clear out the board. See, let's try to convert this number 101. See, when I say 101, so in this bit there is going to be 1 as value, and in this bit there is going to be 0, and this bit there is going to be 1. So let's convert 101 into decimal. So 101, take 1's complement of it, it is going to become 010, add 1 to it, so it's going to become 011. 011 is nothing but 3, so it's going to be minus 3. See, the sign is always going to be minus, because in the sign bit we are having 1 as the value. Okay, so in this case sign bit is very important. So you can observe very carefully, the value is kind of increasing. This is minus 4, then over here we have minus 3, this is going to be minus 2, and this is going to be minus 1. Okay, this is 0, this is 1, this is 2, and this is 3. So now if you look at this variable, what is the range of this variable? See, the smallest value or the minimum value that this variable is holding is minus 4. This is the minimum value of this variable, and this is the maximum value. So now we can say that the minimum value of this variable is minus 4 and maximum value of this variable is plus 3. So range of this variable is minus 4 to plus 3. So this is the conclusion of our discussion. In this way, the variable or the values are getting stored. In this way, the negative as well as positive values are getting stored. Let's quickly recap. See, for the negative values or for dealing with the signed values, I'll say, because in the signed values you have to store negative as well as positive values. So in such scenarios you have to give your most significant bit as a signed bit, right? And with the help of that signed bit, the compiler is going to identify whether it's a negative value or it's a positive value. Okay, it's that easy. Now let's try to create a generic formula by which we'll get to know range of any variable. Let's try to create one generic formula. Okay, so what we'll do is we'll try to take this example, and with the help of this example we'll try to find out the generic formula. Let me just quickly clear the board. Okay, focus very carefully now. See, if we have a 3-bit variable, then the smallest value that we can store is -4 and the largest value that we can store is +3. Okay, now how we can get -4, how we can write it in generic terms. So let's say if we have n-bit variable, so let me just convert it into a generic formula. So what I'll do is I'll write this -4 as -2^3 - 1. Okay, and I'll write this -3 as +2^3 - 1 -1. Okay, just try to get the values for these I'll say expressions. So 2^3 - 1, so 3 - 1 is 2, so 2^2 is 4 and -4. Okay, so in this way you are getting -4, and 3 - 1 is 2^2, so 2^2 is 4, 4 - 1 is 3, and you have plus sign in front of it, so it is nothing but +3. So what we can do is for n bit we can write a generic formula. So it's going to be -2^n - 1, and this is going to be the minimum value, and the maximum value is going to be +2^n - 1 -1. So whenever we have a variable of 1 byte size, so in that case value of n is going to be 8. Okay, so in that case 8-bit, for 8-bit variable you are going to have -2^8 - 1 as a minimum value. So 8 - 1 is nothing but 2^7, -2^7, and -2^7 is nothing but -128. Okay, similarly the maximum value of this variable is going to be 2^n - 1 -1 and positive sign for this value. So 2^8, in this case n is 8, so 2^8 - 1 is nothing but 2^7 and 2^7 - 1, and for this we have to give positive sign. Now 2^7 is nothing but 128, and 128 - 1 is nothing but 127, and over here we have to give positive sign. So a variable of 1 byte size is going to have a range of -128 to +127. So in this way you can calculate the range of any variable. So what is the generic formula? For minimum value this is the formula, and for maximum value this is the formula. So in this way you can get range of literally any variable. In case of integer, n is going to be 32.